The next one we're looking at reads 1 over sine x minus cos x over sine x, all of that squared, and we need to prove that it's equal to 1 minus cos x over 1 plus cos x. I would suggest we start with the left hand side again. Now the left hand side does look like a bit of a nasty one. Let's not square it at first. We're still going to keep it squared, but we've got a common denominator of sine x, so can't that become 1 minus cos x all over sine x squared? Now we can square it. 1 minus cos x squared is going to be 1. Now remember this, 1 minus x squared, or let's rather use, to avoid confusion, 1 minus a squared. That's going to equal 1 minus 2a plus a squared, because it's 1 minus a multiplied by 1 minus a. 1 times 1 is 1, minus a outer inner is minus 2a. Minus a times minus a is plus a squared, right? Using that same concept, we're going to apply it here, except instead of a, we're going to have cos x. So that's going to become 1 minus 2 cos x plus cos squared x over sine x squared is sine squared x. Now, this does look nasty. What I'm going to do, remember that my right hand side has got a 1 plus cos x in it. In the denominator, right? Sine squared x, isn't that the same as 1 minus cos squared x? So I'm going to turn the denominator, I'm going to turn it into 1 minus cos squared x. And I'm going to show you why I did that later on. The numerator, actually look at this, 1 minus cos squared x, isn't that the difference of two squares? 1 minus a squared is equal to 1 plus a times 1 minus a. So 1 minus cos squared x, that can become 1 plus cos x multiplied by 1 minus cos x. Alright, so I made a mistake here, because 1 minus, at the top I've got 1. Before I went to go and square it out, I didn't need to. I could have left it as 1 minus cos x all squared, because now look at this. Let's imagine that I've got a squared over b times a. A would cancel, so that would leave us, that would cancel with one of those, so that would leave us with 1 minus cos x over 1 plus cos x, which is equal to the right hand side. Now please note that I haven't pre-prepared these examples. The reason I didn't pre-prepare these examples is so that you could see that you have to sometimes go through different steps, and you've sometimes got to make mistakes the way I did. Well, not mistakes, but you don't always come to the right answer or the right sort of methodology immediately, but continue looking at your right hand side and see how you can find a link. I had to do that here, and so in the example I did, this top step was totally irrelevant. I could have just left it as 1 minus cos x all squared over sine squared x 1 minus cos squared x. Use your imagination, be creative. You don't have to follow. There is no one way of doing it. The next one I gave you to do read cos 2x over cos squared x is equal to 1 plus tan x multiplied by 1 minus tan x. This one is unique in that I can work at it from both directions. I'm going to start working with this one from the right hand side. right hand side is going to equal, first, before I turn the 10x into sin x over cos x, I'm going to multiply this out. Difference of 2 squares, it's going to become 1 minus 10 squared x. 1 minus 10 squared x is the same as 1 minus sine squared x over cos squared x. 10x is sin x over cos x. This is going to give us cos squared x minus sine squared x over cos squared x. Cos squared x minus sine squared x, isn't that equal to cos 2x over cos squared x, which is equal to the left hand side. Now, if you don't like going backwards from the balance of the equation to the start, for example from cos squared x minus sine squared x to cos 2x, what you could have done in this case was you could have stopped your right hand side there. Right? Now start with your left hand side. You could have said left hand side is equal to cos 2x over cos squared x. Now cos 2x we know is the same as cos squared x minus sine squared x over cos squared x, which means that they are now equal to each other. It is possible to work with both left hand side and right hand side, but don't try and do it at the same time. First go through right hand side or left hand side up until a point you're comfortable with, then do the other side.